So we start with, yesterday we started with the first type of distribution, that is, what was the first type? We started with binomial, right? Probability distribution. So do you remember the formula? Probability of R is equal to, please tell me.
NCR,
NCR, correct?
Raised to R, raised to N minus R.
Right. Where P is what?
Probability of getting
Probability of success. Q is probability of failure. N is the total number.
total
R
number.
is the condition, right, given in the problem. And this NCR is nothing but the combination. Okay, so we know this formula where we have noted that P plus Q is
1.
1, right? Good. So this is where we are, and now we solve more examples on this. So read on the next example. 6 dice. You know dice? 6 dice are thrown. How many faces does the die have?
6.
6. Correct. 6, 729 times. How many times? How many times do you expect? Do you expect at least 3 dice? At least 3 dice to show 5 or 6. Are you getting the question? 6 dice are thrown 729 times. How many times do you expect at least 3 dice to show 5 or 6? Dice, what it shows? You roll the dice. हे माहिती तुम्हाला एक डाय असतं ते आपण टाकलं की एक तर एक पडतो किंवा मग त्याच्यावर 2 असे सर्कल असतात, 3 असतात आणि 6 पर्यंत असतात. That is called die. Okay, so when you throw a die, there are possible 6 outcomes. Either there will be 1 on the upper face or 2 or 3, right? Or up to 6. That is called a die. So such 6 dice you have to throw. How many times? 729 times you have to do that. How many times? Is it the probability? No. How many times is the frequency? And frequency, number of times is actually the frequency, right? And frequency we can find by using probability. I have a formula. So that there is a condition, at least 3 dice to show 5 or 6. Okay, so first of all, we will need a success. So what is the success here? The success is,
At least 3 dice to show 5 or 6.
right. There is at least one. Please ignore this. And dice to show 5 or 6. Give me 1 minute, please. Okay, I'm sorry. Sorry for the disturbance. Chalo. So here success is, you have told me the success. Come again. What is the success here? Your success is?
At least 3 dice to show 5 or 6.
Right. So dice, this is the condition. Condition on R, at least, more than, right? So ignore the condition. How many times do you expect means some probability and then frequency is asked. So at least 3 is the condition. dice to show 5 or 6 is the success. So here success is dice is showing 5 or 6, right? Then you have to define probability of that success, that is small p, right? So what will be p? There is or, and whenever there is or, yesterday I told you, if it is or, what is the probabilities are, and if it is and, what the probabilities are getting. So if there is a or word, probabilities are getting added, and if there is and, probabilities are getting multiplied. Remember that. So if they asked you dice to show 5 and 6. So if there is and, you have to multiply the probabilities, but there is a word or. So if there is or, probabilities get added. Then we have to find for probability 5 and probability of showing 6. You can write like that, showing probability of showing dice showing 5 and probability of dice showing 6. Okay, so what is the probability that dice is showing 5 on the upper face? Can you tell me? What is the probability? बर, आता मी तुम्हाला असं विचारते की तो जो डाय आहे तुमचा, तो तुम्ही रोल केल्यानंतर त्याच्या वरती फेसवर 5 पडण्याची प्रोबॅबिलिटी काय आहे? 1 आहे. किती पैकी आहे ती? 6 पैकी. टोटल फेसेस आहेत त्याला 6, बरोबर? एकतर 1 पडेल, 2 पडेल, 3 पडेल किंवा 6 पडेल. So total such 6 faces are there. So total outcomes are 6. But we want only 5 up. आणि 5 असण्याचा एकच प्रोबॅबिलिटी आहे. एक डाय जर तुम्ही थ्रो करत असाल तर 5 पडण्याचा एकच चान्स आहे. सो 1/6. फेवरेबल आउटकम इज 1. टोटल आउटकम्स आर 6. So dice to show 5 is probability is 1/6. Everyone is getting?
Yes, ma'am.
Right. Then or 6. What is the probability that dice is showing 6? We are
1.
writing probability of 6 also, dice showing 6. How many possibilities that dice will show 6 on upper face?
1.
1 out of
6.
6 again, right? There are total 6, and to show up 6, there is only one such chance. So total probability there is 1/6. So P here is 2/6. 2/6, that is 1/3. Okay, let it be 1/3. We got P. So are you getting? This is something different question, and you can easily find its probability if you know the definition of probability. Number of favorable outcomes upon total number of outcomes. Dice to show 5 up, there is only one chance. Total chances are 6, so 1/6, and similar for dice to show up 6. So P is 1/3. Is there any doubt related to this?
No.
Okay, chalo, we got P. Now we can find out Q. Q is what?
5/6.
1 minus P.
1 minus.
Correct. Right. So 1 minus 1/3. What is that?
5/6.
Minus 1, 2. 3 minus 1, 2/3. Is it 2/3?
Yes, ma'am.
I have
Yes.
something different, that's why I'm asking. Is it 2/3? Correct? Right. P is there, Q is there, and what is N? I'm going back. Just read and tell me N.
729.
29.
No.
6.
Here it is given. What the probability we are writing is for one die, right? Die is showing up 5, die is showing up 6. Such 6 dice you have to throw. 729 is for frequency. Whenever the question is related to frequency, 6 dice you have to throw 729 times. So we first concentrate on the smaller experiment, and then we'll think about the larger one. Okay, so smaller experiment is 6 dice we have to show, we have to throw, isn't it? So what is N? What is n?
6.
6. Okay, so we have PQN, and then I'll tell you what is the 729. That's also I'm going to tell you. So at least 3. Is this the condition? At least 3?
Yes.
Right. So at least 3 is what?
R greater than equal to 3.
Correct. At least 3 means कमीत कमी 3, 3 पेक्षा जास्त, so R is greater equal 3. Means we have to find the probability of this R greater equal 3. Means what? Up to what?
6.
6. Here n is 6. So greater equal 3 means start with 3 and go to 6, or go opposite if you want. So probability of R is 3 plus R is 4 plus R is 5 plus R is 6. Because we are going up to 6 only. Or what you can do is probability of R greater than equal 3 is what?
Less than R.
1 minus probability of R, and 3 I'm writing as it is, greater equal
Strictly
become
less than.
less than. Correct. And what is 1 minus strictly less than 3 includes?
P of R
0,
is 1.
0, 1 and 2.
0, 1 and 2. Correct. 0, 1 and 2. So both are okay. Here we need to find 3. Here we need to find 4. Not much difference. Find anyways. This is also there. So you can go directly if you want. Some people can solve like this. Some can solve like this. Please solve like this first. Okay. So probability of R greater equal 3 is equal to probability of R is 3, 4, 5, and 6. N is 6. 6C R 3. P 1 by 3 raised to 3. Q 2 by 3 raised to 6 minus 3 and minus R. 6 minus 3 is 3. Plus 6C 4. 1 by 3 raised to 4. 2 by 3 raised to how much? N minus R. 6 minus 4, 2. Plus 6C 5. 1 by 3. P raised to R. R is 5. Q 2 by 3 raised to 6 minus 5, 1.
1.
Plus 6C6. 1 by 3 raised to 6 R. 2 by 3 raised to 6 minus 6, 0. Solve this. Tell me answers one by one. Chalo, what is the answer first?
0.21947.
0.21947. Perfect. Find second. Or if you are directly finding the final answer, you can tell me that also. What is second?
0.0823.
0.0823. Perfect. Done with third and fourth. Please tell me what is this answer? What is third one?
0.0164.
0.01646 plus. What one is the last answer of this? 1.3717 into 10 raised to minus 3. Check. Add all of them together and tell me the final answer. How much?
0.196.
3196. Correct. Okay, so this is the required probability of at least 3 dice to show 5 or 6. If you choose 6 such dice. Or chalo, we'll solve our part also. Or probability of r greater equal 3 is nothing but 1 minus probability r strictly less than 3. So strictly less than 3 means 0, 1 and 2. Chalo, solve this also and we'll check whether we are getting the similar answer or not. So n is 6, c is 0, p raised to 0, q raised to 6 minus 0, 6 plus 6c1, p raised to 1, q raised to 6 minus 1, 5 plus 6c2, p raised to 2, q raised to 6 minus 2, 4. Chalo, solve it. We'll see whether we are getting the similar answer. One minus, you will tell me the answers one by one, please. So it is 1 minus, what is the answer of first? 6 is 0, 1 by 3 raised to 0, 2 by 3 raised to 6. What do you get?
0.0877.
Correct. 0.08779 something. Sure. Second one. Go with second.
0.2633.
Perfect. 0.26337. Go with the third one. Third one is this. 6c2, 1 by 3 raised to 2, 2 by 3 raised to 4. Done? Tell me now.
0.329.
Correct. 32921 something. Chalo. Add it and subtract from 1. So what is this addition? 0.68037. Just check whether it is correct. If yes, subtract from 1 and tell me the answer.
0.3196.
31963. Similar we are getting again.
Yes.
If you saw like this, direct from 3 to 6 or indirect opposite way from 0 to 2 and subtract from 1, you will get the similar answer. So that is therefore the probability that at least 3 dice to show 5 or 6 is equal to 0.31963. But probability is not asked to us. What is asked? Find the how many times do you expect? Time is a frequency. Number of times is a frequency. Kiti vera. Barabar? What is the frequencies formula? We have written in last lecture. Frequency is equal to capital N into P of R. Do you remember that?
Yes, ma'am.
Right. So we'll write it here. Frequency. So question is not probability, question is frequency. So we have this capital N into P of R. P of R is the probability of given question. N is the total number. So what is N here? Such experiment, how many times you have to repeat?
729.
Right. So that is your capital N. 6 dice you are throwing. 729 times you are repeating the same experiment. Right. So your N is here 7 and 29. Okay. And you have probability also. Here it is the probability. So if you multiply that probability with the given number, we'll get the frequency. So that is equal to, so therefore frequency is equal to N. What is N? 729 into probability. That is we have to, we have already find 31963. Do this, you will get the answer.
3.01.
233.01. But as it is a frequency, it can be a number, not the points. So
233.
Right.
2, 3.
Frequency is always a perfect number. So it is 233. Means what? When we throw 6 dice 729 times, out of which at least 3 dice are showing 5 or 6, 233 times. Are you getting?
Yes, ma'am.
Right. So therefore you can write it if you want at least 3 dice to show 5 or 6. At least 3 dice to show 5 or 6 when 6 dice are thrown 729 times is equal to 233. Done. So your final answer is 233 times. Whatever is the question, this is the answer to that question. How many times? So 233 times. The dice will show 5 or 6. Sure. We'll go to the next question. Is there any doubt in this?
No, ma'am.
Sure. Write the next question then. In a locality, 20% people smoke. Find the probability that out of 6 persons, chosen at random, from this locality, 4 or more will be found to be smokers. And whenever the question probability comes, we'll define first the success. The success is, will you please tell me the success?
4 or more people will be found to be smokers.
Okay, I told you earlier also, 4 or more is the condition. We are not taking the condition in regard. So condition, we take it in consideration into the probability finding, right? So before, whenever we are writing success only, ignore this part, number, 4 or more. So what is success?
A person to be found to be smoker.
Right. A person found to be a smoker. Right. So right here, success is a person to be a smoker. Whatever is the question, that is your success. So a person to be a smoker is the success. So can you define P? P is the probability of success. A person to be a smoker. And we are finding the probability that a person smoke. And it is given that in a locality 20% people smoke. So what is P? 20%. Or what
0.2.
can, right, 20 by 100. That is 0.2. Correct?
Yes.
Right.
Yes.
So Q is 1 minus P, 1 minus 0.2, that is
0.8.
0.8. Perfect. And N, what is N here?
6.
6 persons chosen at random. Very good. So N is moderate 10, 20. So we can go with binomial. So binomial distribution formula is NCR, P raised to R, Q raised to N minus R. Right. And what is the condition here? 4 or more is the condition. Means what? R is
Greater equal to 4.
4 also or more than 4 also, 4 or more. So this is 4 and more than that. So 4 or more, R is greater equal 4. Means we are finding this probability of R greater equal 4. Greater equal 4, we start with 4 and we go up to
6.
6. Okay, we'll go like that. So as N is 6, so 4 is there, plus 5 is there, plus 6 is there. आणि उलट गेलं तर 0 पासन 3 ना, 0 1 2 3 म्हणजे 4 करावा लागेल आणि सरळ गेलं तर 3च करावा लागेल. मग असंच जाऊयात 4 to 6. चलो फाइंड आउट that. Probability of R greater equal 4 is, probability of R is 4 we are writing. So N is 6, C4, T, what is P? 0.2.
0.2.
Right, raised to R is 4 into 0.8 raised to 6 minus 4, that is 2. Or you can write here 6 minus 4. Then 6C5, 0.2 raised to 5, 0.8 raised to 6 minus 5. Plus 6C6, 0.2 raised to 6, 0.8 raised to 6 minus 6. Do this. You can just write 6 minus 4 as 2 while solving on calculator. Don't write 6 minus 4, write that 2. What is the answer to the first?
0.0153.
Correct, 0.01536 plus. Solve second.
1.536 into 10 raised to
10 raised to
3. So minus 3.
minus 3. It should be minus because probability is in 0 to 1. Na? Plus, next, third one. What is that? You are solving this.
6.4 into 10 raised to minus 5.
Right, 6.4 into 10 raised to minus 5. Add all of them together.
Zero point zero one six nine.
0.01696 something something.
Yeah.
Okay, so this is a required probability. The question was find the probability. Yes. So we are done. This is the required probability. Done. Next question. Is there any question in the doubt in this question?
No, ma'am.
So we'll go to the next question. Out of 800 families, with 5 children each. With 5 children each. How many would you expect to have? First question, 3 boys. Second, 5 girls. Okay, there are 2 different questions. Out of 800 families, how many families? Families, number of families means this is the question of frequency. And when we are finding frequency, we must first find probability. Okay, so to find the probability of these two, in first define the success. Success is out of 800 families with 5 children each family is having 5 children. How many would you expect? How many families would you expect to have 3 boys and 5 girls? So what is the success in this case, in question 1?
Having 3 boys.
Having 3 boys.
3 is the condition. Ignore. Having
Boys.
boys in a family. Having boy. Instead, a boy. 3 is there, so that's why boys. Having a boy in a family is a success in first case. So we have to define P here. What is P? Probability of success. What is the probability of having a boy in a family?
0.6.
No, just let me know what is your thinking. Having a boy in a family. So what is the probability of having a boy in a family?
1/5.
No, in a family. We are talking particularly about a boy.
1/3.
No, why 3? No. 3 boys, this is 3 is the condition on R. Okay, don't go with that now. Having a boy in a family. So I am expecting the total and expected, and such way you will tell me the probability. In a family, what we can have, we can either have a boy or a girl. So what are the total outcomes in a family?
5.
No, in a family, don't confuse. This is 5
Here of 3
children.
plus 5.
Wait, there are 5 children. We'll go later to that case. 5 children. But having a boy, किती असतात फॅमिलीमध्ये, काय काय असतं? बॉय असू दे 2 किंवा गर्ल्स असू दे 3, काही फरक नाही बोलत आहे मी जेंडर बद्दल बोलतेय. एक तर घरात बॉय असतील किंवा घरात गर्ल्स असतील. सो टोटल
1.
आउटकम्स काय आहेत घरात? 2 आहेत ना, त्यातलं तुम्हाला बॉय पाहिजे फक्त. Total outcomes are 2, that is boy or girl, and out of which you want only a boy. So boy is having, means it is 1. Are you getting?
Yes.
Yes, ma'am.
Okay.
Yes,
So having a boy, so there can be a boy or girl. So total outcomes are 2, and having boy means 1 on that. So Q is here 1 minus P. There is 1
1.
minus 1/2. 1/2 again. Right. PQ is there. What is N? Out of such 800 families with 5 children each. So what is N?
5.
Now we are talking about children. So there are 5 in each family now. So N is 5. Now condition on R for the first question.
3.
3 exactly equal to 3. Probability of having 3 boys. So R is 3. So we are writing here formula NCR P raised to R Q raised to N minus R. Put R is 3 here, N is 5. So 5 C3. P is half, half raised to 3. Q is again half, half raised to 5 minus 3. Do this. Five minus 3, that is 2. And half half is same, so it is 1 by 2 raised to 5. You can do that also. Sure, tell me.
0.3125.
Correct. 0.3125 is the probability of having 3 boys. If there are 5 children in each family, out of that 5 children, 3 boys, probability is every family is having 3 boys. Out of these 5 children, the probability of such is 0.3125. So now it is not just a probability asked, it is asked the frequency. So out of 800 such families. So how will you find?
N into probability.
Right. So you are writing total number of families expected to have 3 boys is equal to N into probability of having 3 boys. 3 boys ची probability जी आली है त्याला into the total number. So N is 800 ना?
Yes.
800 into probability of 3 boys 0.3125. Multiply and find the answer. That will be the number of families.
250.
250.
250.
So 250 such families will have only 3 boys. Second question now. 5 girls. What is the success?
Success is having a girl in family.
Right. Success is having girl in a family. So what is P?
1 by 2.
Is it again 1 by 2? Total
Yes,
are
1
again
by
boy or girl, that is 2, and out of which we want girls, so 1 by 2. Q is 1 minus 1 by 2, that is Q is also 1 by 2. N is, will N
5.
change? No, it is same, N is 5. Formula also the same, NCR, P raised to R, Q raised to N minus R. Solve it. But R is what here? 5. 5 girls. So R is 5. N is 5, R is 5. 5C5, 1 by 2 raised to 5. And again 1 by 2 raised to 5 minus 5, that is 0. Do this.
Zero point zero three one two five.
Correct. 0.03125. This is the probability of having 5, all 5 are girls. Such is the probability. So total number of such families, write that. We need the frequency. Total number of families having 5 girls is the total number of families into the probability of 5 girls. So the total number is 800,
25.
right? Into the probability is 0.03125. So are you getting 25? Just check. So there are 25 such families out of 800. We will have all 5 girls there in their family. So are you clear with a frequency also now with probability?
Yes.
Right.
Yes, ma'am.
Good. Next question. If in a lot of 500 solenoids, if in a lot of 500 solenoids, 25 are defective. 25 are defective. Find the probability that there will be 0, 1, 2 defective solenoids in a random sample of 20 solenoids. In a random sample of 20 solenoids. Random sample of 20 solenoids means what is n here?
20.
20, correct. So 20 is good. We can use for binomial. So define the success.
Success is getting defective solenoid.
Right. Perfect. Your success is, read that. What probability is asked? Find the probability that there will be, forget about this 0, 1, 2, defective solenoids. So success is getting defective solenoids. Okay, so define P. P is the probability of getting defective solenoids. P is the probability of success, you know that. So probability of success means probability of getting defective solenoids. Define. What is probability? P. Read it. If in a lot of 500 solenoids, 25 are defective, so what will be the probability of defective solenoids? Number of favorable outcomes upon total number of outcomes. Favorable means defective. So 25 are defective. Upon total number, how many are total? 500 are total. So this is what the P is. Remember formula also. If directly it is not given, use the formula and find P. Check it out. What is your P?
0.05.
0.25.
Right, 0.05. Q is 1 minus P. That is 1 minus 0.05. How much it is?
95.
0.95. Correct. And what is N?
20.
Right. In a random sample of 20. So N is 20. And what is R? There are three different. There will be 0. First question is 0. Second is 1. And 2. Three different questions are there. So 0 defective solenoids means R is 0. So question 1, 0 defective solenoids means R is 0. Chalo solve it. N is 20, C 0, P 0.05 raised to 0 into Q 0.95 raised to 20 minus 0. Solve it.
0.3584.
Correct. 0.3584. आगे one more digit.
8.
8. Good. So this is the probability of getting 0 solenoids. Second, 1. Means what is R here? Condition?
1.
1.
1. So do that. So R is 1. Means probability we are finding R is 1. So in formula, replace your R by 1. 20 minus 1. That is 19. Do that.
0.3773.
Correct. 0.377. Again, 3. Good. Second is done. Third now. This is very important for MCQ type exams. Okay. Easy आहेत. Solve होतात. विचारले जातात. R is 2 here. The probability of R is 2. We are finding. So 20C2. R is 2. P raised to R. Q raised to n minus R. 20 minus 2. Solve it. You will get the answer. And the question is probabilities only, not the frequencies. So we are getting the probabilities.
0.1886.
0.1886. Right. Perfect. So this is how we can solve binomial distribution questions. Firstly, we'll need a success. If you define the success, go with P, then Q, then N, then R. There will be answer. Okay, next question. Is there any doubt in this?
No, ma'am.
No, sure. Next question. For a binomial distribution, this is important for MCQ type again. For a binomial distribution, the mean is 2 and standard deviation is 1. Find NPQ for binomial distribution. Mean is and standard deviation is. Tell me now. We have written the notes. Everything is on that note now. For binomial distribution, what is the mean?
NP.
NP.
Very good. NP. And what is the standard deviation?
Root NPQ.
Root of
Perfect.
NP.
Root NPQ. Right. So mean, it is given here. Mean is 2. Right. So it is 2. And standard deviation is 1. So standard deviation is 1. Means we get NP is 2 and root NPQ is 1. So taking squares of this, what is NPQ?
1.
1 square is 1. Okay. So we get that. If you want, you write here squaring. Okay, these two equations we have with us. So from this, what we can find?
Q.
Q. So divide this by this. So we get NPQ by NP is equal to 1 by 2.
By 2.
Right? NP get cancelled. So you get Q. Q is 1 by 2. You got it?
Yes.
Right.
Yes.
Q is there. So we can now find P. How? How can we find P?
1 minus Q.
Right. So for binomial distribution, we know one more thing. That is P plus Q is 1. So here P is nothing but 1 minus Q. Solid. So P is equal to 1 minus Q is what? Half, no? P is also half,
1 by 2.
right? P, Q, we got. Can we find N also? We have to find N. How can we find N?
P plus Q.
Okay, but P plus Q is 1 and we want N. Can we use it here? NP is 2 because we have P, no?
Yes.
Right? So if you want, you can call it as 1 and 2 also. And what we did here is divide that 2 by 1. We did here. And now in 1, from 1 we can solve. What is that? NP is 2. So, but P is 1 by 2 is 2. So 2 is divide here. It get multiplied to this side. So 2 into 2, 4. So N is 4. Got all the values? It can be asked in exam. Please remember. Chances are there. Okay, the next question. Is it clear to everyone? We just need the two formulae. Accordingly, we can solve Q by dividing just, and then we can find P also. And if we have P, we can find N also by the definition of mean. Chalo, so next question can be true or false. Such question can be there if it is. The question is, the mean of binomial distribution is 15 and standard deviation is 5. Whether this statement is true or false.
False.
How can you say that?
Variance can never be greater than mean.
Do you remember the statement? I have given in notes. Variance can never be greater than mean. Okay. So here, what is the variance here? Variance is nothing but standard deviation square, right? Standard deviation is 5. So 5 square is 25. Variance is here 25 and mean is here 15. Means variance here is greater than mean. Is it possible?
No.
Which
No.
is not possible. This is for you. Variance can never be greater than mean. So given statement is a false one. Or if you don't remember at the instant the statement variance can never be greater than mean, then we have one more option. Variance is 25. That is what we have. Variance. Definition of variance in binomial distribution. NPQ. NPQ is 25. And mean is NP. And NP mean is 15. So from this divide, we will get Q is equal to 25 by 15. So what is that? 1 point something. 666. Q is 1.6667. Is it possible?
No.
No, as it is greater than 1 and probability can never be greater than 1. That's why also it is false statement. If you don't remember actually this variance reasoning, you can write here variance, but variance can never be greater than mean. Okay. So yes, false statement. One more statement I'll give you. Please tell me whether it is true or false. The mean of binomial distribution is 12 and standard deviation is 3. True or false?
True.
True. What is variance here?
9.
9, correct. 3 square. So 9. And mean is 12. Your variance is less than mean. Yes, variance is not greater than mean, so it is a true statement. Correct. Is there any doubt? Please wait, I'm taking attendance. Do not leave. In between, if you want to ask me something, you can go ahead and ask if you have any doubt. Disha, you haven't got the roll number 8?
No, ma'am.
Okay. Kaushiki is also there. Rutuja is there. Please ask for your roll numbers so that from next lecture we can put
Yes,
your
ma'am.
attendance. Okay. So yes, this is all from my side. I'll stop here. Thank you. Bye-bye. Take care.